this morning for our office tenant webinar for the month of June. We're excited to have so many of you on today's webinar to talk about conducting your own energy audit of your own space with or without being sub-metered and having your own utility bills, and sort of with or without the assistance of your property manager. Couple of things to note if you haven't participated in a webinar previously with us. We do encourage you to join using your telephone. That'll make the Q&A portion easier. And to do so, you select the Use Telephone option in your audio box of the webinar software. And there's 3 numbers that will appear: your phone number, access code, and your audio pin. And the audio pin is important so that we can mute and unmute you when you do want to ask a question. All of you will be in listen-only mode until we get to the Q&A portion of today's agenda, which will be at the end of the webinar. So during that time, if you would like to ask a question or have a statement you'd like to make, just simply click the raise hand icon on the dashboard of the webinar software, and we'll go ahead and call on you and unmute you to ask your question. If you've opted to join us via your computer speakers, then the easiest way for you to ask any questions or say anything will be through the chat window of the webinar software, and we'll go ahead and read anything that you comment on out loud and address the speakers for you. As with all of our webinars, today's webinar is being recorded, and it will be made available on the arlingtongreengames.com website at the bottom of our Events tab. So here's a glance at today's agenda. We have a lot of great content to share with you, and we'll save the last 10 or 15 minutes of today's webinar for the Q&A session. Just a quick update, we have a little over 120 competitors now joined with the program. That represents about 1/3 of the county's commercial office square footage, so we're really excited for those numbers. And due to its popularity, we have expanded the registration deadline until the end of June. Those who join between now and then will obviously have a little bit of a shorter period of time to complete their actions and make improvements. Everybody will still be on the same schedule of submitting their final scorecards by the end of February 2012. All of our participating office tenants, you should have received an email from us with your debrief scorecard and a comparison to the averages and other participants in the Green Games. We are continuing to conduct one-on-one follow-up meetings to discuss your results. If we haven't done so with you already, we're more than happy to come meet with you. And one of the average scores for the energy scorecard is a 7.9 out of 30 points, and so that's the topic area that we're going to be focusing on with today's webinar. And I think there's obviously some room for improvement, so we hope to address some of those issues today. And so with that, I'll hand it over to Sarah, and she'll introduce our first speaker.
Thanks. Good morning, everyone. So first, this morning we're going to hear from Steve Jarovic. Steve is a senior associate with Cadmus Group and has more than 20 years of experience in the energy and environmental field. Dr. Jarovic supports EPA's outreach effort to the architectural and engineering communities to improve the energy performance of new buildings. He also works on improving the energy performance of existing buildings, particularly through the use of EPA's building rating scale called Portfolio Manager. Before joining Cadmus, he worked for the Southern Environmental Law Center, analyzing the costs and impacts of demand-side management programs, and worked as an independent energy consultant evaluating building heating, cooling, and lighting loads. So welcome, Steve.
Thank you. Thanks very much, and thank you everybody for joining the session today about reducing energy use in an office environment. I'd like to get this to full screen mode, so bear with me while I...
The bottom right-hand corner where you see it says 98%, click the little icon to the left of that. Yep, that one. There you go.
Got it. Thank you. Okay. So this is our agenda for the next 20-25 minutes. We'll be first talking about some of the benefits of reducing electrical energy use in an office environment. Many of these I imagine you've heard before and are certainly familiar with, but we'll touch on a couple of highlights. And then we'll indicate the several areas in which people who are working in an office have an opportunity to reduce electricity use. That is through some audit and then some particular actions to bring that about. Then we'll touch upon the specific measures that one can do. What precisely can you look at to identify ways in which to save energy? And then we'll kind of summarize the findings. So the particular benefits are really the first one, and the primary one is to reduce the emissions of carbon dioxide into the atmosphere. When one is using electricity that is coming from some electricity generating station, and at that generating station there are huge emissions of carbon dioxide, particularly from a coal-fired power plant. This is much less obviously in gas turbines and other kinds of generation, but about a half of our electricity is generated at coal-fired power plants, and they're a major source of CO2 emissions. Of course, another benefit is to reduce the energy costs. The money that is not going to pay utility companies can be used for the purposes of the organization, whether it's government or it's private industry. And a secondary benefit is that you reduce air conditioning costs. That is, equipment in the building, whether it's lights or computers or anything, gives off heat, and that heat is proportional to the energy being used. So if you cut back the energy, you will cut back the heat, and then you'll reduce your air conditioning costs, which are, given this summer, getting to be very important. And of course, the actions that we take in any particular setting will have some sort of an outwelling effect, whether it's talking to other people or businesses, talking to other businesses. This will spread, and this is all beneficial in terms of what we're trying to achieve. Now, this is just kind of a summary of the different sectors of energy use within a commercial building. This is kind of identifying the various ways in which energy is used in a building. And if you look at some of the major categories like space heating, space cooling, and lighting, that's almost half the energy in a building, about 49%. And if you add in then the usage from computers and other electronics, plug loads, you're up about 58%. So that's a huge chunk, and that's really what we'll be talking about as we go forward. The 13% for adjustments to SEDS is just a measure that the Department of Energy computes to sort of reflect the uncertainty in all the other different categories. So it's not an isolated energy use that we can really identify. It's just a measure of uncertainty. Now, these are some of the opportunities that we'll talk about. First, within the lighting, and there are several places in lighting that we'll touch on. Then with computing equipment to reduce energy use. Then office equipment in general, that is like copier scanners, faxes, and so on. And then vending machines. And buildings often have vending machines out in the halls or in break rooms and other things, and that's another source of significant energy use in which one can take some actions to cut that back. Now, just a couple of basics on electricity use. We want to distinguish between site versus source. When we talk about the site energy use, we're speaking about the energy that's used in the building that you're in, that is at the site in which we're all sitting. Source energy use is the energy that's expended at, let's say, an electricity generating station. And the ratio of source energy to site energy is, as you see there, it's over 3.34. In other words, it takes about 10,000 BTUs of energy at a coal-fired power plant to deliver 3,000 BTUs to the site. So it's a significant difference between source and site energy. When you're burning natural gas on the site, the difference between source and site is just a fraction over 1 or about 1%. But for electricity, it's an enormous difference. And this is because of all the different conversions of energy that take place at the electricity generating station, and then the losses in transmission over power lines and the losses in distribution stations as the voltage is stepped down to the amount that buildings can accommodate. Now, in terms of carbon dioxide emissions, the national average is about 1.54 pounds of CO2 per kilowatt hour. So that's what's going into the atmosphere from the energy that we're plugging in and using in our homes and in our buildings. For the state of Virginia, it's a little bit less than the national average. It's about 1.12 pounds of CO2 per kilowatt hour. And just to give you an indication of that, you can see that a single 100-watt bulb, 8 hours a day, will throw 450 pounds of carbon dioxide into the atmosphere per year. So it's significant. And it's really significant because of that huge difference between source and site energy. Now, let's look at some specific measures and then subsequently the way in which you can audit here. So for lighting, first is to have efficient fluorescent lighting in the building. If we have T12 magnetic ballast lamps, they can be replaced with either T8 with electronic ballast or T5 with electronic ballast. And you can just look up at the lights and look at the diameter of that lamp and get an estimate of whether you have T12s, T8s, or T5s. If the diameter of those lamps looks to be about an inch, that's a T12. If it's about less than an inch, 2/3, that's a T8. And if it's less than half an inch, 5/12, that's a T5. So you can look at that yourself and just kind of make a quick glance and understand what's up there. Another way is through occupancy sensors. That is, do you have conference rooms or other offices that are only occupied intermittently, and sometimes the lights are just left on all the time? An occupancy sensor can then turn those lights off automatically. Obviously, you can have manual switch operation just to sort of raise awareness through maybe some notice near the light switch. If you're the last one leaving this room, turn the lights off. So that's another thing that can be done to try to reduce the energy use. And of course, replacing any incandescents that are in the office setting with compact fluorescent lamps or LED net lighting now. So those are other two choices, highly efficient sources of energy, significant energy reductions. Another one is to look at the exit signs, and there are lots of exit signs all over buildings. And you can possibly see the difference between LED exit signs and the standard ones. Standard exit signs generally will have two 20-watt lamps in them, which means it's about 40 watts versus 5 watts for an LED exit sign. So it's another place to really reduce energy use. Hallways, by code, can be less bright than office space. Your office might be 50, 75, even 100-foot candles, which is very high. If your hallways are equally bright, they can be reduced to a lower wattage, lower lumen output, and you'll be saving energy there as well. And lastly, I just wanted to put in this identification about meters if one is really feeling ambitious here. Obviously, when you leave the building on nights and weekends, you don't know whether the lights are left on or they're not left on. And oftentimes when we inquire, we're not always getting the accurate answer. It's certainly the one that people believe is happening, but sometimes things happen with respect to settings, and that's not what's happened. So there are lots of little sensors that one can get. I am only identifying one of them, and this is by no means a recommendation. It's just an example. There's a small sensor, hobo sensor. It's about 2 inches long by about 1 inch wide. You can put it on top of a bookshelf, and it will record at, say, 10-minute intervals the light level in the office. And you can come back and dump out the data after a week or 2 weeks and see whether your lights are dropping down to 1 or 2 or 5 or 10 lumens at 2 in the morning, or whether they're still up there at 50 lumens. So it's a way to do that. Now I've got at the bottom 2 web places where you can use look at for information about Energy Star qualified lighting, as well as other recommendations about efficient lighting products. The first is the EPA's Energy Star website, energystar.gov/purchasing, and the other is the website from the Department of Energy for the Federal Energy Management Program. That's the FEMP listed there. Everything that's Energy Star is on the FEMP website, but it also identifies things that are not on Energy Star, so it's a great source of some additional information about efficient products. Now, how would you audit this? You, an individual in the office setting. Well, as we mentioned before, you could just look up at the fluorescence, and if that looks like to be about a 1-inch diameter lamp, then that's a place where you can say, we could save by converting over to T8s instead of having T12s. Also, if you look at the exit signs, if the exit signs are sort of fully lit and smooth, that's probably a regular bulb in there that's probably using 40 watts. If it has the distinct little dot pattern, about a 1/2 inch or less than 1/2 inch dots, that's probably the LED exit signs, and that's sufficient. So you can look for those things around the building, and you can understand that you can make significant savings by replacing those exit signs. Also, look for spaces that have occupants that may be suitable for occupancy sensors, as we said, like conference rooms and offices. If people come in the morning, often leave for several hours, come back, that'd be a great place to have an occupancy sensor turn those lights off automatically. And of course, identify places for light switch reminder notices. This again may be conference rooms and other places where a little notice by the panel would remind people to turn the lights off. And again, check brightness of the hallways. If they're the same as offices, you can probably save energy there. And lastly, identify locations of incandescent lamps. These can be replaced with CFLs and LEDs and significantly reduce your energy use. Now let's go over to another source, which is computing equipment. And here, the main thing we want to mention is monitor power management and computer power management. Now, it may be on your monitor that you're looking at that if you step away from the monitor within 10 minutes, it drops black. That means it's going into low power mode, and you've got power management with that monitor. With a computer, it's probably not the case. We think that only about 15% of the computers across the country have computer power management on here. But the savings are about the same as with monitors. Monitor power management will save you about 90% of the energy from what it's on when it's full. Computer, if they drop into low power mode, will also save you about 90% of the energy. So it's worth doing and worth looking into. Another is night and weekend control. Those computers do not have to be on overnight. They don't really have to be on the weekend. And if someone, if your organization tells you that you need to leave the computer on because of the rollout of updates of software at night, there are ways to do that. We'll touch upon that in a moment, about how you can wake up a system for a software upgrade. EPA's calculators for power management indicate that the savings per system is about $52 a year at the average price for electricity. EPA also allows one to sign a low-carbon IT pledge, and it just says, we'll make a change to power management, and we have X number of computers. We'll do this over the next 2 months or 6 months or a year. And if you sign that pledge, you can get no-cost EPA computer power management support. In other words, you get technical support for implementing computer power management at no cost. And there's the website that connects you over to the power management information. So how to audit some of this, you individually? Well, one, you can do it on your own computer. You can just go to the control panel, then go to power options, and you can look at what's enabled on your particular system, and maybe you want to enable it yourself to put in power management both in your monitor and your computer. Or you can ask your IT manager about what happens if you're connected on a large network. The IT manager may be having something taking place automatically. And EPA does offer software that will do that automatically on a network of systems. And you, as I mentioned, you have power management for both displays and computers. And in fact, the savings with computers are larger generally than with the monitors, so it's really worth doing. And that low-carbon IT pledge is really a good way to get no-cost EPA technical support for implementing this. Now, for office equipment, we have all this range of products like scanners, copiers, printers, and so on. And what you want to do is to enable low power mode and to turn off that equipment during nights and weekends. So you can take a look at that equipment, or maybe get a support person to look at that equipment and see if low power mode is enabled on there. And then to make sure that that equipment is turned off on nights and weekends, except possibly fax machines. If somebody's possibly sending a fax late at night, those things have to be kept on, but all the other equipment really does not. Then duplex copying, to be sure that the copiers are set automatically for duplex mode. And of course, to purchase Energy Star qualified equipment. And we've got that list of equipment there. And that's the website below to check. In other words, you can go to that website and you can check for any piece of equipment, whether it is Energy Star qualified or not. So how to audit this? As we've mentioned, you can check if the equipment in your office is Energy Star qualified. Just take down the manufacturer's equipment name and the model number, and you can go to that website. You can look up that particular product type, like scanners, copiers, and you can see the list of all the equipment that's Energy Star qualified, and you can check if it is. Also then, of course, check if duplex is your copier default. This is really important to do. And check if your equipment is off during nights and weekends, and it may take some support person, or maybe, who is turning this off on Friday night, or who's turning this off automatically. The equipment will often drop into low power mode, but that's still using a fair amount of energy if it even sits in that overnight. And there's no problem in turning it off. And I should mention that with respect to computers, we sometimes heard years ago that computers shouldn't be turned off, that it wears out the electronics faster. That's absolutely not true. You can go to the EPA's website and it will tell you that that's absolutely not true. So if you turn off a computer, if you're going to lunch, you'll be saving energy and you will not be wearing out your machine. That may be inconvenient to do that, but depending on the boot up time, but it's certainly not hurting your machine, and it certainly is not the case that you should be turning them off because you're wearing it out. Now the last one I want to touch on is vending machines. Again, as I said, these are often in place in break rooms and hallways in offices. And if you look at, say, a 500-can unit, the conventional machines will use about 3,900 kilowatt hours per year and cost about $400 per year for the average electricity price. The Energy Star qualified machines are less than half that cost, $170 a year. So conventional machines can be upgraded to the performance roughly of Energy Star machines. So whatever we're getting from the product sale, in other words, we probably are getting something for all the sodas that are sold out in that machine, the energy costs can really diminish that profitability. And it's really worth checking whether those things are at Energy Star level or not. So these can be audited again. Look if your machines, or check if the machines are leased or owned. Then find the make and model number, and that's usually on some kind of metal panel on that machine, and check if it's Energy Star qualified. You can do that right there. If you see a little small, what essentially is an occupancy sensor at the top of the machine, it's probably been modified to be Energy Star. What that little occupancy sensor is doing is looking if anybody's in the neighborhood of that machine, and if not, it's turning the lights off. And that's one of the ways in which it saves energy. And as soon as you enter the field of that sensor, and the lights will go back on, and it's coming back to full power. So if it's not Energy Star or doesn't appear to be, you can contact the leasing agent or management about upgrading it. And there's a product, VenMiser, that will upgrade that to about the level of an Energy Star machine. So in summary, individuals in an office really can identify savings opportunities with lighting, the overhead lighting or exit signs, with computing equipment using power management, with office equipment, again, power management, duplex copying, things like that, and with vending machines and checking that they're up to the performance of Energy Star qualified vending machines, because it's twice the cost if they're at the conventional level. So the Energy Star calculators enable cost savings determination. That is, if you go to that website I listed for Energy Star, energystar.gov/purchasing, you'll find calculators like Excel spreadsheets up there, and you can calculate the difference in annual and life cycle cost for conventional versus Energy Star qualified products. And there are a number of resources on the EPA and the FEMP websites that you can use to identify potential savings. So there are indeed major cost and emission savings possible that you individuals in the office can do to identify savings opportunities. So if there are any questions, I'll be glad to take them, and that's my contact information there, and I'd be glad to have questions from anybody at any time if you want to email me or give me a call.
Great. Thanks so much, Steve. We are going to go ahead and jump into the next presentation, and then we can take some questions at the end to make sure we have time for everything. So next, we're going to hand it over to Robbie Soders, who is an account executive for CNR Lighting, a lighting distributor specializing in energy-efficient lamps, ballast, controls, and more, located in Herndon, Virginia. Robbie comes to CNR with 15 years in the business and 12 years as an electrician. He is fully capable of handling all your inquiries, including walkthroughs for lighting planning and product choice, as well as planning for a construction job. So go ahead and turn it over to you, Robbie.
Great. Thank you very much. I want to thank everyone for being here today. This is a great opportunity, and I think what Arlington is doing is fantastic. I wanted to talk today about doing just very basic, simple calculations to find out basically how much 1 watt of power is costing you per area. Now, I don't want to make this a big math class and make this more confusing than it is. It's very simple calculations that once you get the hang of it, might take a little bit, but once you get the hang of it, you'll start walking through your areas and see. Do these calculations in your head just out of habit. And basically, all right, the 1 watt method is what we call it, and it's a simple way to calculate and identify areas that consume plenty of electricity. And this is, again, this is per area, not per your entire floor. Say that you have 10,000 square feet of business space or office space. This does not take into consideration the entire area. Just certain, maybe the foyer areas, or maybe an open office area, or individual offices. Each one has to be done separately because it's based on how many hours of operation each individual area is using. And again, this is very simple, but the more you think about it, it's very, very easy to overthink how it works. Believe me, it's taken a little bit for me to catch on to this, but again, it's very simple once you get going. We'll take a basic scenario, an open floor plan, which is simple cubicles. And in the area, we have 54 lamp fixtures, and each fixture has already been retrofitted to have the T8 lamps, and each lamp is 32 watts, which is pretty much a standard that's on its way out. And we'll talk about that a little bit more later. So the calculator is basically, we're going to take the operating hours, multiply it by the total watts that's in that area, and multiply it by the energy rate that you pay through the power company, which I believe is Dominion Power. And we'll find out what this costs. Let's say a general office setting scenario where the lights are on, 8 to 5, it's 9 hours a day, 5 days a week, 52 weeks per year. We do that calculation and it comes up to 2,340 hours per year. Pretty simple so far. Now we need to convert this to kilowatt hours. Now kilowatt hours is a unit of electrical measurement of energy. This is how the power company determines what your usage is. Basically, your meter measures everything in kilowatt hours. So kilo means 1,000. So we need to divide the operating hours by 1,000, and that gives us 2.34 kilowatt hours per year. Based on our 2,340 hours. So now what we're going to do is figure out how many lamps and, or actually how many wattage, how much wattage we're actually using in this entire area. And again, our scenario was 54 lamp fixtures with 4 32-watt lamps. And again, this is pretty simple. We take 50 fixtures, multiply it by 4 lamps. There's 200 lamps. Multiply it by the total watts, and we have 6,400 watts in that area. So basically, right now, what we have is 2.34 kilowatt hours. Multiply it by the kilowatts. And a typical energy rate in Northern Virginia is somewhere between 10 and 11 cents per kilowatt. Again, everything is based on kilowatts. So we multiply that all out. That gives you $1,647.37. That's what that entire 50 fixtures is costing you to run per year. Now, here's a simple calculation that's not on here that gives you a better idea of where this is going. If we take that kilowatt hour rating, which is 2.30, and multiply it by the 11 cents, it gives us just over 25 cents per watt. So that's basically what this is all about, is trying to find out how much each watt is costing you. Again, this is per area. So areas that are on 24/7, 365, you're going to be somewhere around 50 to 60 cents per watt. But right now, this is just a basic scenario that shows that we're looking at about 25 cents per watt. Now, there are energy efficient possibilities to replace that 32 watt lamp with. Right now, Philips has a lamp out that's a 25 watt equal to the 32 watt. One thing I do need to clarify, though, is a lot of people get confused and they say, okay, well, we're taking out a 32 watt and we're putting in a 25 watt. Am I going to get the same light output? Yes. Wattage is not light output. Light output is lumens. So essentially, the 25 and 32 watt have the same lumen output. Watts are a unit of energy used. So what we do is, if we take the same calculation and utilize a 25 watt, we're basically saving $360 a year just by a simple lamp change. And those lamps right now are about the same price as a 32 watt. So as you start to see lamps go bad and they need to be replaced, you want to take a look at just maybe upgrading to a 25 watt standard. The EPA, I guess, came out with legislation a couple years ago, and it's starting to come into effect. And your 32 watts are going to be around, but they're slowly phasing out based on the price and the efficiency. Other things to consider when you're looking at your lighting load. I see a lot of times where we have tenants just hopped up on their chair, hop up on their desk, and yank a lamp out of their fixture and think that, yeah, you're losing a little bit of light and we're saving some electricity. That's not the case. That ballast that's in the fixture that's driving those lamps is using the same amount of electricity regardless of how many lamps are in that fixture. In fact, if you take a single lamp out of a 3-lamp fixture, the ballast is actually going to push the additional energy or electricity that it has to the other 2 lamps. And you're going to get roughly the same light output. You're just overdriving those lamps. You're going to kill the ballast, and you're going to burn out your lamps a little faster. So what can you do? As your maintenance guys or property managers come through your facility, or if you guys do it yourselves, just replace the ballast with a 2-lamp ballast. Very simple to do, and typically most of your older buildings were overlit in the first place. Computers may not have been used quite as much as they are today. There's not a whole lot of paperwork generally that's done anymore. And if it is, simple task lighting can be used. Little LED table lamps, under-counter lamps, anything, just to get a little bit of light onto your desk, and just kind of leave the ambient light or the light overhead just at a minimum, and that's going to keep your lighting load down. Again, a simple 2-lamp ballast can reduce the light output and just give it a nice cozy atmosphere. So basically, if we take a 2-lamps out of your 4-lamp scenario fixture that we were talking about, again, you're cutting your energy costs in half at that point. So basically, a 32-watt lamp would become $823 a year, and your 25-watt lamps would be $643 a year. So again, it's very simple stuff that can be done, very, very minimal cost. A ballast, you're looking at about $12 a piece. A 25-watt lamp, you're looking at maybe $2 a piece. Excuse me, $2 a piece. Other options, as was mentioned before, occupancy sensors do a fantastic job. But there are things that are new technology, I shouldn't say new, but technology is coming this way very shortly. It's called vacancy sensors. Typically, all of our standards come from Europe or originate in Europe, and then they migrate their way to California. California tries them for a couple years, and then they start to come east. Right now, California does not recognize occupancy sensors as a sustainable way to reduce energy. They pretty much standardize everything on vacancy sensors. Vacancy sensors is basically a manual on and auto off. Occupancy sensors are still a good option. I think people are enamored by the fact that they walk on, their lights come on automatically. Yay, it's great, but you know what? If you're out to lunch, the office the lights are out, and the mailman decides he needs to come in and drop something on a desk, or a coworker needs to put something on your desk, and you're not there, the lights are out, walks into your office, occupancy sensor kicks on. Guess what? It stays on 15, 20 minutes, whatever, until it cuts off. Did you really need that light to put the paper on the desk? No, you didn't. So right there's simple ways that we can not turn the lights on. And typically a lot of your occupancy sensors already wired internally to be a vacancy sensor. Some of them just have a simple dip switch on the back of them that need to be switched and convert them to a vacancy sensor. A lot of times people have a lot of complaints with occupancy sensors that are like switch mounted because they don't see them behind the computer or around the corner. They do make now wireless wall mounted sensors that basically it's very simple as pushing a button on both sides, letting them mate, and they're linked. So that's another option to avoid the nuisance switching that the occupancy sensors have. Now, typically we're seeing that the occupancy sensors usually save about an hour a day in use or occupied office spaces. So by reducing your lighting load or in certain areas 1 hour, you're going to save $183 per year for each hour that per day that you're reducing your lighting load. So basically a summary of what we've done, basically a 32-watt lamp and a 4-lamp fixture, you're looking at about $1,650 per year. 25-watt lamps and a 4-lamp fixture, about $1,287 a year. And if you add a vacancy sensor, occupancy sensor to a 32-watt fixture, you're reducing your cost by just under $200. And the same with a 25-watt vacancy sensor. And then if we go to a 2-lamp fixture and just buy a simple ballast replacement, you're reducing again your cost of the 32-watt lamps to about $824 per year, and the 25-watt lamps, your total cost of usage is $643 a year. And again, by subtracting the 1 hour a day for the occupancy sensors, you can see where you start to rack up some big-time savings. Now, a couple of questions I get a lot. People are starting to see and advertise the LED fluorescent tube replacements. Just a word of advice and a little bit of warning that there's hundreds of manufacturers out there pushing those guys. There's only 2 of them that are UL listed, and if any of those non-UL listed lamps decide to fail, start a fire, your insurance is not going to cover them. It's going to be a fantastic option, but for a $30 lamp versus a $2 lamp, and they're both going to last about the same amount of time, right now it's not viable to go that route. LED is a fantastic option in its place. We just need to take a look at it and make sure we're putting it in the right spot. Again, that's my contact number. I'm available anytime to do a walkthrough with your facility and give you some different lighting options and help you with keeping your lighting sustainable. Thanks.
Great. Thanks so much, Robbie. Nice to be able to connect the financial metrics with some of these environmental and energy changes that folks can be making in their buildings. We appreciate that. So our third and final speaker today is Kate Marshall. Kate is a principal with SRA International's Energy and Environmental Services team and has 13 years of consulting experience. She leads SRA's Sustainable Community Technical Assistance Practice Area, managing sustainability-focused projects for federal, state, and local governments. Kate is also a member of SRA's Go Green Advisory Panel, providing technical guidance to enhance SRA's sustainable practices. So welcome, Kate.
Thank you so much. And Robbie, you've given me a little bit of homework today because I've actually removed some of the light bulbs in my office, and I don't know if I'm saving energy or not. So as soon as I get off the call, I'm going to go check that out. So I'm here today to provide an example of how we have done a lighting retrofit in our building in Arlington Center, Virginia. And I'm trying to advance my slide here. Can I get a little bit of guidance on that?
You should just, as you would normally, just click or press your space bar or something. Or the arrow keys.
There we go. Space bar worked. Thank you. So SRA has a building in what we call our Arlington Center building. It's located at 3434 Washington Boulevard. So if you're familiar with that stretch of road, we are just behind the giant grocery store and also adjacent to the George Mason campus. So it's about a 200,000 square foot building, and we have more than 600 of our environmental staff located here. We have about 5 floors of space, and it's a mostly closed office plan. And we are about halfway through our lease at this point. We're leasing the building from George Mason University Foundation. And we've been working with a series of great property managers that have really helped us think through how we can improve the energy use in our building and improve our performance overall. Our space in this building was originally built out to qualify for LEED Silver back in 2005. We didn't go through with the certification, but the building was built out to those specifications. And we have been Energy Star labeled. We are currently in the process of getting our application in for this year, so hopefully we'll get that very soon. And we've taken a look at our building's energy performance relative to other buildings, and there's something called an energy performance rating, and that's basically a percentage estimate of how your building performs against other U.S. commercial buildings. And back in 2007, when we first applied for our Energy Star label, we had a rating of 88%. So we were performing better than 88% of U.S. commercial buildings, which we were pretty pleased with. But we've been looking for ways to try to improve our space and reduce our energy consumption. So in summer 2010, we took on a project to retrofit the lighting in our building, much as Robbie just described. We had almost 1,800 3-lamp fixtures that were using 32-watt bulbs. And we also had motion detector light switches in the building, but we wanted to see if there was a way that, or what the savings would be if we were to reduce the wattage from that lighting. So the cost for us to go through the building and relamp and ballast all of those fixtures was about $24,000. At the time, though, we were able to get a Dominion Power rebate that came out to about $7,000. So that offset our total cost and brought it down to about $17,000. So looking at the other side of our cost-benefit analysis, we took a look at what our savings were going to be. And our energy savings, just from switching from the 32-watt bulb to a 28-watt bulb, was about $7,800. And in addition to that, we were able to calculate what our lamp savings would be. Essentially, the new lamps lasted longer, on average, than the older lamps that we were using. So we were estimating that we could save about $1,600 per year from the lamps themselves, from not having to replace them quite as much, plus our energy savings. So our total payback per year was about $9,400. The payback period that we were looking at was just under 2 years, which I think is a very quick return for a project like this. And we're calculating that across the entire building, we're currently saving 86,000 kilowatt hours per year. So we've seen a significant reduction in our energy use for a pretty quick payback period. The effort that we did in Arlington Center to retrofit our lighting is similar to what we did at our headquarters facility, which is out in Fair Lakes. And we did a similar lighting retrofit back in 2009. This was before the Dominion Power rebate was offered, but we still went through and took a look at the costs and benefits. As you can see in the picture, this is a much bigger facility, and the cost to retrofit the building to bring in motion detector light switches, as well as replacing all of the lights, lamps, and ballast, was a much higher cost as well. It was about somewhere between $150,000 and $170,000. But because we were able to combine the change in the lighting with the motion detector switches, our payback was just about the same amount of period of time as we had in Arlington Center. It was 1.8 years. So again, this was a great lesson for us and something that we'll be looking to do in additional facilities. The other thing that was great about this project in our Fair Lakes facility was that it helped us qualify for the Energy Star label out there. When we first applied for that Energy Star label, we didn't have quite enough points to qualify for it, but the energy or the lighting retrofit that we undertook really helped us push our application over the edge and give us what we needed to qualify. So looking back at the Arlington Center project, one of the things that did make it really appealing for us is that we were able to qualify for the Dominion Power rebate. It definitely decreased our payback time. It brought it to under 2 years, which was a nice return of investment, especially since we are leasing the facility. So we were looking for a shorter payback time than if we had owned the building outright. The application process for getting that rebate was very easy. There's an inspection process associated with it where Dominion Power has to come out and inspect your facility. And that took a little bit longer, but overall it was a pretty great way to offset the costs from the project itself. And one of the things that we noted is that our building's energy performance rating improved from when we first measured it back in 2007. I mentioned that our building performed better than 88% of U.S. commercial buildings in 2007. Today we're at 94%. So we're proud of our facility and that it's performing so well compared to so many other buildings. Looking ahead, we have changed our corporate standard now to use the 28-watt lamps at other facilities based on the great successes that we've seen in our Arlington Center and our Fair Lakes facilities. We haven't yet gone through a full energy audit for the building, but we are looking to doing that in the next fiscal year and looking to see where there's some other ways that we can improve our performance even further. And one of the ways that we're going to be looking to do that is through some behavioral changes. And we're currently looking at developing our own internal energy performance label. And I have a couple showing here on the screen are examples of what an energy performance label is. And it's essentially a incremental measure of your building's energy performance. So you can see how you're trending over time in terms of your total energy usage. And what we'll be looking to do is to look at our monthly or quarterly energy usage and give ourselves a rating and post that up in the facility so our staff can see it on a daily basis. And getting everybody that works in this building really thinking about the energy being consumed and coupling that with some behavioral changes like changing the power settings on your computers, talking about the use of space heaters, and how we use our lights in the facility. So this energy performance label, this is consistent with our new county energy plan. So we're going to be looking to do this on a voluntary basis and are really hoping that this will help us kind of make that next leap forward in terms of energy savings. So hopefully this is kind of a helpful practical example of how buildings in Arlington can improve their energy performance, and I'd be happy to answer any questions today or offline if you're interested in kind of the more technical details of what it is that we undertook here. So thank you.
Great. Thank you so much, Kate. It's terrific case studies, and thanks for sharing those successes with us. So now we'd like to go ahead and open it up to the group for any questions for any of our presenters, whether it's for Steve or Robbie or Kate.
So to ask a question, again, there's a little raise hand icon button on your dashboard of the webinar software. If you're joined over the telephone and want to ask your question or provide a comment verbally, please click that little button and we'll call on you. And otherwise, if you prefer or if you've joined over the computer speakers, feel free to type your comment or question into the chat window. So we'll just give you a moment or two. There's been a lot of great information, a lot of data and calculations and things. So any questions that you have for any of our speakers, we'll give you a minute to think about it.
And while you're thinking of questions too, just wanted to remind everyone that there are still currently rebates available through Dominion Virginia Power. So there are rebates available for both lighting and HVAC. So you know, if that's something that you might be interested in pursuing for your office space or maybe even on a broader scale across your building, those incentives are available.
All right, not seeing any questions coming in. We do want to remind you of our upcoming events. On June 9th is our Mingling Monday. Yes, that is a Thursday. We were working to accommodate our speaker who's with DC government, and he runs their green purchasing program, and he'll be providing details on how to set a green policy, how to set up a green purchasing program, everything from creating a policy, evaluating where you're at, where you're going, and whether or not it's feasible to purchase various kinds of green products from a financial standpoint. And then our brown bag in June, we will be talking about the community energy plan, which is something that Kate just touched briefly on, but we will have representatives from our team here at Courthouse Plaza to talk to you about the development of this plan and the impact on the business sector and how you can be engaged and involved as we move forward with that initiative. So I guess with that, we don't see any questions coming in. So we want to give a big thanks to all of our presenters for all this great content. I know we'll be posting it to the website, and we'll certainly be connecting any of you with them as you do have questions or need for information. So thanks a lot, and have a great day.
Thank you.
Thank you.